Hey guys, this is Joe with the Adapt team, and in this video I'm talking about Adapt in SIMPL Windows. I want to talk about how Adapt was really born and really kind of where we came from, because we still use a lot of these mechanisms still today. And what I'm referring to here is a mechanism called crosspoints. So crosspoints were a way in SIMPL Windows for us to define all the touch panels and devices in our system and have touch panels, or really any user interface, talk to these devices. I set up my touch panels and connect them to crosspoint IDs or crosspoint symbols. I set up my devices and connect them to their equipment crosspoint symbols, and then I can connect any touch panel to any device from this crosspoint connect symbol. This was really nice because it essentially was 3 buffers in one, so it helped me eliminate the use of those buffers, of course. One of the really cool things is that we now got to reuse join numbers on our touch panels, and this is something that we still do in Adapt, where we essentially set up one chunk of join numbers in our touch panel hardware definition, and that one chunk of join numbers controls every device in my system, and it's just based on whatever device I'm currently controlling. The joins then get propagated through to control that device. This model also scaled really nicely. It's very obvious, how do I add additional touch panels? How do I add additional devices? Then we kind of realized that this model needed to evolve because it didn't really represent how a user actually uses the system. We wanted a user to be able to go into a room, pick up a remote, and turn that room onto that source, and don't have to worry about anything else. And with crosspoints by themselves, there's quite a bit of extra work needed to actually pull that off. So this model kind of evolved, at least for us, into a model that we called layered crosspoints. With layered crosspoints, the user now controls a room from any user interface, and that's the top half of this diagram, is the user controlling a room, just like what was on the previous slide, except now a device is actually a room. And then the second layer of this is that the program now understands all the devices that are contained within that room, and that's the bottom half of the diagram, where the room is actually a control crosspoint, and the devices within that room all interface with that room that they're contained in. And this was really nice because this aligned with how the user actually controls the system. But unfortunately, some of the connection logic became really confusing and difficult to debug when you talk about all these things connecting downstream from one another. And actually, you kind of had to invest in your own framework or scheme in order to really make it work, and we certainly made that investment as a programming company, but we knew that this couldn't scale and this couldn't really make us last into the future, and so we again kind of evolved this model into Adapt. And so Adapt still borrows from a lot of these concepts, but we've made it quite a bit simpler, and here's how we've done that. First and foremost, we want this to be user based, right? And so as far as the user is concerned, all that your user needs to worry about is picking up a user interface or going to a user interface and controlling a room, and that's it. That's all that the user worries about, is going to a UI and controlling a room, or maybe multiple rooms if they're using a touch panel. And then we think about, okay, how does this translate into a programmer actually doing his job? The first thing that we know as programmers is that when a user pushes a button on any of these user interfaces, that's really just hitting a signal on that hardware definition. Maybe it's a keypad, touch panel, or handheld, but that button press comes in from a hardware definition. And then we need to find a way to connect that to a room, or have this logic for what a room is. And so what we did is we set up our user interface modules, almost kind of like their control crosspoints like we saw on the last diagram. And instead of a crosspoint connect symbol, we instead have our Adapt core, our simple sharp Adapt core, managing all of this connection logic for you, so that you don't have to worry about all that complicated connection logic. And so essentially from here, our Adapt user interface modules communicate to our Adapt core. The core is what understands, okay, these devices are in this room and these devices exist in the system that's available for configuration. And so it's our core that then communicates out to device Adapt modules that exist in our system. You see I have some here for audio switchers, video switchers, but also things like lighting and windows and door locks and cameras. And so it's our Adapt core core that communicates with these other adapt modules. And then finally, these adapt modules actually interface with the hardware definitions to actually make the hardware do what our user expects it to do. And so that's how adapt is kind of designed, is that instead of control cross points, we have touch panel modules, and instead of equipment cross points, we just have adapt device modules, so to speak. Each of these modules then connects up to their respective hardware, and everything works out very nicely for us. And so when we're building our very own simple Windows programs, like we're going to do in just a sec, we want to think about, okay, how do I start and where do I go from there? And we call this our adapt programming flow. And the way that you start any adapt program is you're going to start in simple Windows, and you're going to define all your hardware. This is where you're bringing in adapt modules and connecting them to their respective hardware. So of course, the first step in this is you want to add your Crestron IP IDs if you're using Crestron gear, or you're going to bring in your third-party module if that's how you're controlling that particular device. And then you're going to add in your adapt modules, or bring your adapt modules into your program and connect those adapt modules to those hardware definitions, whether it's a Crestron piece or a module. And this is what we mean by define our hardware. We do this for every single device in the system. We then compile our program, right? Because we're still in simple Windows, so these programs still compile just like they always have, and we load them just like we always have. And then we're going to want to retrieve our adapt configuration file using System Manager. And of course, we'll do this a little bit later in our tutorial series here. But System Manager is where we're then going to be able to configure our hardware. This is where we say what devices exist in all of these different rooms that are in our system. We're also going to do other things like defining inputs and outputs. So where do our sources go, which outputs go to which rooms, things like source names, device timings, button labels, touch panel configuration. We get to do a whole lot of configuration type stuff in System Manager, and after we are finished configuring our system, we're done. And so that's the programming flow for adapt. Now, when you are ready to start your very first adapt program, the good news is that we've actually already started your program for you. We call this program the Adapt Starting Template. You can find it in our examples folder in our Adapt suite. And what this program is essentially a starter program that has a couple things already done to it. It has one of each touch panel type already programmed and set up for you. And it also has some of the most popular Crestron audio and video switchers kind of already in there and ready for you to use. And I'll talk about how we can use these to our advantage in just a sec. And the other thing that this program has is nice organized logic folders ready for us to place adapt modules from our symbol library and drag them into our program for us to use. So this is where we want to start all of our programs. So it's important that actually the very first thing we do after opening up this starting template is doing a save as, so that we don't muck around with this starting template too much. And so I'm going to do that right over here. I'm going to tab over. Here you can see I've got my starting template program open. I haven't done anything to this yet. The first thing that I want to do is I want to go ahead and do my save as. I'm going to go ahead and save this to a directory I've got on my desktop. Kind of show you how we recommend that you organize all your files. So obviously this is my main job folder. I want to set up a folder for my interfaces that I'm going to place my VT Pro projects into later on. And then we want to have a folder, or at least we recommend that you have a folder for each processor that's on your job site. Of course, you may have more than one processor on your job site, so keeping those folders organized per processor right here. And then, as you may know, each processor can run up to 10 programs simultaneously. So in this folder here, we create a app folder essentially for each program slot that's running. Right now I'm just focused on my first program slot, my adapt slot, and I'm just going to finally name my simple Windows file here. So we're going to call this adapt training residence. I like to be as descriptive as possible in my file names. Maybe I go a little bit overboard, but with this type of file name, I know exactly which processor, which program slot, and I'm keeping track of my version numbers with this file name. And so I'll go ahead and perform that save as right now. Now, the system that we are going to be doing today, or what I should say is the best way to learn how to do adapt, is to program a system from scratch. Program a real system that would be deployable. The system, or we've kind of put together a system for you that we're going to call the Adapt Training Residence. This is a fictitious system that we've put together that we think represents a good kind of middle ground when it comes to Crestron systems that we see in the wild. So this is a distributed system. So we have a C2 and amp 6x100 for audio distribution. We have video distribution through our DM 8x8. We're going to have a bunch of various TVs with a good handful of sources that you see down here. And we're going to have a special theater zone like we typically run into, and we're going to control this entire system from the various user interfaces that are out there in the wild. And hopefully the idea is that this system hopefully represents a typical system that maybe you come across. Maybe this is about middle of the road. You may have some systems that are smaller, some that are larger, but by programming and executing this type of system in this training, you should get a taste for how to scale back for smaller systems or how to scale up for larger systems. Okay. Now the first thing that we're going to do in our new saved as program is we're actually going to take a look at the very last module in our entire program called our boot up module. And this module is a little important, so I have a slide just for this module. This module has a couple important signals on it, but actually before we get into that, this module does need to be the very last module in the entire program. This is essentially what controls our boot up sequence, so it is important that this is the very last module in the program. So a couple signals on this module that are important, and how we use them is also important. The first one is this init signal. This init signal should only connect to other adapt modules, and we'll see us use this throughout our training experience, but essentially this init signal only goes to other adapt modules. Another signal that we see here is program is ready. This is a signal that latches high when the adapt boot up sequence is complete. Oftentimes we use this to start polling various devices or establish TCP connections, anything like that we use program is ready for. And now we move down to the parameters. The first parameter that you see here is the job name. This one is important for when we create our adapt configuration file. You're not going to want to change this parameter after you've loaded to your processor the initial time. So make sure that you pick a job name that you want to stick with so that you don't have to change it later on. And lastly, we have our adapt license. This is a parameter that's used for activation purposes. And what you want to do is you want to take your adapt license from our dealer portal and copy and paste that into this boot up module here under adapt license. And like I said, this is what's used for activation purposes, and there will be a separate video on activation a little bit later. Okay, so what we're going to do now is we are going to make sure that we have all of our information inputted properly into this boot up module before we get ready to add some of our first devices. So obviously my first signal here is this job number parameter. I'm just going to fill that in with job adapt training residence, and I'm going to make sure that I do not change that throughout the course of this project. My dealer name, I'm just going to fill that in here. We are Pantech Design. The adapt license, I would want to go to my dealer portal and make sure I copy and paste this. I've got my adapt license right here, and I'm going to go ahead and copy paste that right there. Obviously, I have init and program is already defined already. If we were to follow these signals out, you would see that init currently does in fact go to other adapt modules that are already in my starting template, and program is ready. We've used for various signals throughout our program, including this user prog init one, which tells the processor that our adapt sequence is done booting up. And I think the last thing I'm going to do in this video is we're going to go to our project header and just make sure that some of our program header information is set up correctly according to our job. My name is Joe. And I think that will just about do it for this video. If you are able to join us in the next video, we're going to be adding our first device type, an audio switcher, and we'll really hit the ground running from there. So we'll see you there. Thanks.